When I first got started in web development, cloud storage buckets were a relatively new technology, and getting user-generated files uploaded to the cloud was a major pain point. But luckily today we have Firebase, which makes this process much easier but just as flexible for the developer. In today's video, you'll learn how to build a drop-zone style file uploader in Angular that can handle multiple concurrent files to Firebase storage. If you're new here, like and subscribe, and grab the full source code from Fireship.io. I created a similar video about a year ago, but the #1 request has been a system that handles multiple files concurrently. So in this demo, you can drop as many files as you want onto the drop zone, and then you can pause or cancel each individual upload. The cool thing is that Firebase will handle all of the concurrency under the hood, so you can have your users drop as many files as you want here, and Firebase will choose the best strategy to get those files uploaded to the cloud, which is based mostly on the user's network connection. And another thing we'll do is save the download URL to this file in Firestore. This makes it really easy to access the raw file if you're already using Firestore in other parts of your application. Now I'm going to show you how to build the drop zone from scratch in Angular, but one thing you should check out is this custom file drop element from Google Chrome Labs. It has nothing to do with Angular, but because web components are awesome, you can just drop it into your Angular app and start using it. So this might be a good alternative for building your own custom drop zone. Let's go ahead and get started. First, I'm assuming that you have an Angular app along with Angular Fire and Firebase installed. If we take a look at the app module, you can see I have Angular Fire Storage and Firestore. Then if we take a look at the CSS for this application, we have a drop zone class, which is just a flexbox with a border. Then we have a hovering class that will change the border from dash to solid when the user hovers over the box. And all the other styles come from a framework called Bulma, which if you're not familiar with is a cool alternative to Bootstrap or Material. The first thing we'll do is generate a directive that will be able to turn any div into a drop zone. And by drop zone, I just mean an area that the user can drag and drop files to, and then we can receive those files as an event in our web application. So we'll go ahead and call that directive drop zone, and its responsibility is to receive the files and then emit them up as a custom event that we can listen to in other components. In Angular, we create custom events by using a combination of output and event emitter. This allows a parent component to listen to events that happen in this child directive. In this case here, we're creating a custom event called dropped that emits a file list. And a file list is built into the browser, and it contains the actual files that the user dragged onto this element. Then we'll also emit a custom event called hovered that will tell us whether or not the user is hovering over the element so we can toggle that border. From here, we're going to use host listener to intercept the drop event in the DOM. Drop will happen after the user drags a set of files over to the drop zone and then lets go on the mouse. Normally, this would cause a new browser tab to open, so we call event prevent default to stop that from happening. From there, we want the directive to emit the files out as a custom event, and we can access the files by calling event data transfer files. And we'll also go ahead and emit false through our hovered event. So that takes care of the file drop event. We also want to listen to drag over and drag leave, then emit true or false depending on whether or not the user is dragging over the element. And that takes care of the entire directive. You now have a way to compose this logic into any component or element in your Angular app. Now we can move on to the actual file uploading logic. Because we want to handle multiple concurrent file uploads, we'll have a parent that manages all of the files that the user dropped, and then each child component will manage the actual upload of that file. You can see here I've generated two new components. One is the uploader, that's the parent, and then one is the upload task, that's the child. Let's start with the logic for the parent component. It's going to have a property isHovering, which we can just use to toggle the border on the drop zone, and it also has an array of files. First, we'll define this toggle hover event handler, which will just flip that property from true to false. Then the onDrop event handler takes the file list as its argument. The file list contains all of the files, but it's not something that we can just loop over directly with a for each loop. So instead, we have to set up a traditional for loop here, and then we'll add it to the array of files on this component. The reason we do this is so we can pass each individual file to a child component in the Angular template. Now we can go into the template and we'll set up a div here with our drop zone class, and then we'll add that drop zone directive that we created earlier. This gives us access to the custom events that we created, like hovered and onDrop. Then Angular has a built-in class directive that we can use to toggle the hovering class whenever the isHovering property is true. We could stop there and the drag and drop feature would work perfectly fine, but it's also a good idea to add a file input field so users on mobile devices can just click a button to upload, or for those on desktop that just don't want to drag and drop. We can use the same onDrop event handler, but for the argument, we'll want to pass the event target files. And the event itself is the change event on that form input. The last thing we need to do here is loop over the array of files. Each file will be passed as an input property to the child upload task component. Now it's time to move on to the upload task, and that's where we'll write the code that actually uploads the file to cloud storage. We'll start by importing our Angular Fire dependencies and a few things from RxJS. And in this demo, we're going to have the upload start as soon as the component is initialized. But you could easily modify this to make it more lazy if you want the user to push a button first before it actually uploads the file. First, we decorate the file property with input so it can be passed down from the parent component. Then we have the AngularFire upload task, which does most of the magic for the file upload itself. Then while the file is uploading, it provides a couple of different observables that we can listen to monitor the progress. Percentage and snapshot will help us do that. Then we'll also display the download URL for the file when the upload is complete. From there, we'll add our dependencies to the constructor, which are AngularFire storage and DB for Firestore. Then we'll define the upload logic in its own method, and then run that method as soon as the component's initialized. And again, you could extract that out to a button if you want to make it a lazy upload. The first step is to define the path in the storage bucket where this file will be saved. I'm also adding a timestamp to the file name just to ensure that it's unique. You don't have to do this, but keep in mind that file names need to be unique, so if you upload a file to the same location with the same name, the latest one will override the old one. From there, I'll use storage to make a reference to that actual location in the bucket. Then calling upload will start the actual file upload to Firebase storage. It's not an observable, there's no need to subscribe to it, but it does provide observables that we can use to monitor the progress of the upload. Percentage changes is just a number ranging from 0 to 100 that makes it easy to create a progress bar. Then snapshot changes is an observable that emits an object every few hundred milliseconds with a bunch of data about the file upload. It contains the bytes transferred as well as a bunch of other information, so I recommend you console log it so you can take a closer look. Then RxJS has a finalize operator that runs after this observable is completed. I've experimented with a few different approaches here, but I think what makes the most sense is just to add an async function that gets the download URL and converts it to a promise. The reason I like this approach is because we first need this download URL before we can run our update to the Firestore database. And with async await, we can just do this in 2 lines of code. We first get the download URL, and then we make a reference to the files collection and add that document to the database. As a final touch, I'm adding this isActive method, which will tell us whether or not an upload is currently running. This just makes it easier to disable the cancel and pause buttons based on the state of the upload. Now at this point, we just need to unwrap our observables in the template. I like to unwrap the observables inside of ngIf and then set the value as a template variable. This allows us to use this % variable just like a synchronous value in the template. We can set this as the value to our progress bar and then also display the raw value as well. We can unwrap the snapshot in the same way. That'll give us access to the bytes transferred, which we can then compare to the total bytes of the file. And then we can also display our download URL in here as well. But the coolest part is that the AngularFire upload task allows us to control the upload itself. For example, if we want the user to be able to control the upload, we can add a pause button here and then just call task pause to pause it. Then we can do the same thing for cancel and resume. And lastly, we'll use that isActive method that we defined earlier to just disable these buttons depending on the current state of the upload. If we go back to the demo and start uploading some files, we should get results that look like this. Each individual file will have its own progress indicator, and if we click pause or resume, it should react accordingly. And if we pull up the Firestore database, you should also see the download URL being saved there as well. Hopefully that gives you a good starting point for your own file uploading system. If this video helped you, please like and subscribe, and make sure to grab the full source code from Fireship.io. Thanks for watching, and I will talk to you soon.